Alright, in the last two videos, we've seen that activating groups tend to be orthopara-directors, and deactivating groups tend to be meta-directors. The halogens are an exception to this, and an exception for another reason, and so we want to consider them separately. So, I just mentioned this, but electron donating groups are generally activating groups, and they're orthopara-directors. Electron withdrawing groups are generally deactivating, and they're meta-directors. The exception to this is the halogens. They are electron donating, but in fact, they are orthopara-directors. So the halogens sort of have this competition between induction and resonance that we also saw for the methoxy group. Halogens withdraw electrons by induction, but they can donate electrons through resonance. Again, I'm repeating myself a little bit, but the electronegative chlorine, because it's more electronegative than the carbons and hydrogens, will withdraw electron density due to induction effects, which would make us predict it to be deactivating. When we consider the resonance structures, the presence of the halogen would appear to be electron donating, because we can draw these resonance structures that have the negative charge in the ring. For the methoxy group, we said that resonance was more important. And so this is one of the big exceptions. Most of the time, resonance is more important. In the specific case of a halogen, it turns out that the induction effects are more important. So for the halogens, induction is more important, the resonance is less important, and so that makes the halogens deactivating. Now, generally for deactivating groups, they are meta-directors, but in the case of the halogens, and again, for the directing, we're always going to consider resonance. We don't have to worry about induction anymore. When we look at the resonance structures of the sigma complex, just like we had for the methoxy group, we can get these resonance structures where, when we add the nitro group to the ortho and para positions, where we can give everybody a complete octet. I can't get that resonance structure from attack on the meta position, and so this stabilizes the ortho and para sigma complexes, and that makes the halogens ortho and para directing. And I do want to point out, it may be difficult to see how we get this resonance structure coming from this resonance contributor. I think it's more obvious when we start at this one, right? If I have this resonance contributor, I can just move the lone pair down. And so it's only when I can get the positive charge on the carbon directly connected to the halogen that we get this especially stable resonance contributor. I never get that when we add the group in the meta position. The positive charge ends up here, here, and here, and so I can't do this resonance contributor. Whereas in para, the positive charge is here, directly adjacent to the halogen, and so I can move that lone pair down and get this particularly stable resonance contributor. So to summarize, halogens are deactivating, but unlike most deactivators, they are orthopara-directors as opposed to being meta-directors.